Welcome back to Arxflix. Today, we're diving into a paper titled Measuring Faithfulness in Chain of Thought Reasoning. This research investigates whether the step-by-step reasoning provided by large language models, known as chain of thought, or COT, is a faithful reflection of the model's true reasoning process. Here's an illustration of the tests proposed in the paper to measure the faithfulness of COT reasoning. The tests include early answering, adding mistakes, paraphrasing, and filler tokens. Let's break down what the research found. The core issue is determining if the reasoning generated by the model is actually used by the model to reach its final answer. The researchers discovered that models show varied reliance on COT across different tasks. Sometimes they heavily rely on COT, and other times they mostly ignore it. To explore this, the paper examines several hypotheses through various interventions on COT. The three primary hypotheses are post hoc reasoning, unfaithful reasoning due to test time computation, and encoded reasoning. The first method is early answering. By truncating the COTs at various steps and observing the model's answers, researchers measured how often the model's answer changes. If the model's answer changes frequently, the model is likely not generating post hoc reasoning. This figure shows the chance of giving the same answer as the complete COT after truncation. Large variations across tasks indicate different levels of post hoc reasoning. Another test involves adding mistakes into the COT and observing if the final prediction changes. If a mistake leads to a different answer, the model isn't simply ignoring the COT. Results show that tasks like Aqua and Logica exhibit changes in the answer, thus showing less post hoc reasoning, supporting the hypothesis that the COT is integral to final predictions. The filler tokens test replaces COT with uninformative tokens to see if the extra computation time alone explains better performance. Adding filler tokens didn't improve accuracy, suggesting that the COT itself primarily influences the model's performance, not just additional computation. The third method, paraphrasing, rewords the COT to see if specific phrasing impacts the model's accuracy. Paraphrased COTs yielded similar accuracy to original COTs, debunking the idea that phrasing encodes crucial, unstated reasoning. Importantly, the research finds that smaller models tend to produce more faithful COT reasoning than larger ones across a variety of tasks. This figure shows that as the model size increases, faithfulness tends to decrease. Smaller models rely more on COT and thus produce more faithful reasoning. In summary, this paper reveals that COT reasoning can be faithful, but it depends heavily on the model size and the task at hand. The results suggest choosing the right model and task combination to obtain more faithful reasoning, opening pathways for designing more verifiable AI systems. That's all for today's breakdown. Thank you for watching, and don't forget to like and subscribe for more insights from cutting-edge research papers. See you in the next video. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.